look at what is vector space. Starting from what is a vector. So starting from the basics, let us take an example like vector of like this. So 2 units in x direction and 3 units in y direction. It means 2 units in x direction, 3 units in y direction. So this vector can be plotted on a xy plane like this. 2 units, 3 units. So you have a vector like this on xy plane. All right. This vector can be represented like in another style like this. So as I said, this vector can be represented like this, and where we have the x component like this and the y component on the downward side. And this again we can plot, or we can show this vector as like this. Okay, now let us take different vectors as an example. So vector could be 1 0 minus 1 2. These are 2-dimensional vectors, and let us plot these vectors as well. So we can plot this very easily on xy plane. So vector 1 0 is over here, right? 1 0 over here, minus 1 2, minus 1 2 is over here, minus 1 2. Okay, now if we add these two vectors, so how we can add these two vectors? Like simply by vector addition we can add this vector. Like the x component will be added to x component of the other vector, so this is 0, and the y components will be added, and this will result as 0 2. Okay, and now we can plot this vector in this plane as well. And if you see, you have 0x component and 2, so the resultant vector is this one, and this resultant vector can be written as and can be shown as this. So this vector again lies in the same xy plane, right? So the idea of vector space is when you add two vectors, 2-dimensional vectors, I mean to say, and you end up having the vector, the resultant vector in the same xy plane, like this one. So this xy plane is regarded or considered as a vector space. The whole xy plane can be considered as the xy plane. What does the criteria, the conditions? 2 conditions must be fulfilled for a space or for a vector space. One is that the addition of vectors. Suppose if you have one vector x1 and the other vector x2, then the addition of these two vectors, suppose for example x3, this vector should lie in the same plane. x3 should lie in the same plane as x1 and x2. And the other condition is, so as we have seen that the resultant of these two, addition of these two vectors, lies in the same plane. We have seen that. Okay, and the other condition is when you multiply the vector first with some constant a, some real number, and when you multiply the vector 2 with b, then the resultant vector, for example x4, for example. So this the resultant vector should also lie in the same plane, in the same xy plane. I mean where the x1 and x2 lies. So x4 should also lie in the same plane. After fulfilling these two criteria, 1 and 2, fulfilling these two criteria, 1 and 2, you can say that xy plane, the given xy plane is a vector space. So vector space is nothing, it's a space, it's a plane which satisfies two criteria as I mentioned before. I hope you understand what is a vector space. For example, let us take an example. It's very easy to understand what is with the help of an example. So suppose if you have a vector 1 2 and the other vector through 3 1. So when you add them like this, so you will end up with 4 and 3. So you can see this vector also lies in xy plane, right? And so second condition, if you multiply the other two vectors, suppose with 1 into 1 2 plus 0, that constant a and b could be any number, real number. So if you multiply the second vector with 0, you will end up with plus 0 0, right? And you will end up with this vector 1 2, and we know that this vector also lies in xy plane, right? Then we can say that the xy plane is a vector space for two-dimensional vectors. Why it is two-dimensional? Because the two vectors that I mentioned in our above example has two elements. One is x component and the other is y component. That's why we call it a two-dimensional vector space. You got the point? Two-dimensional vector space. I hope you guys understand the concept of vector space. Okay, one more thing I would like to add into it. So when we say xy plane is a vector space, it means it also includes the zero, the origin, as also a part of vector space. Why I'm saying this? So when you multiply let us take the example of the above two given vectors 1 2 and 3 1. 1 2 and 3 1. So when you multiply this first vector with 0 and you add up the other vector multiplied with 0, you will end up with 0 0. This is the origin. This is the origin. This one. This is 0 0. So what I mean to say is the above vector space also includes the origin as a part of the vector space. I hope you understand the concept of vector space, essentially a two-dimensional vector space. So we can represent this, the xy plane, as a vector space like this of two-dimensional vector space. Okay, this is a two-dimensional vector space. I hope you understand this point.